Okay, so I hope you remember last time we were discussing kinetic molecules, in the end of the class. And what we have discussed so far was molecule. So we already know what does molecule actually mean. Then we discussed another postulate that explained large number of molecule, right? Then we were talking about the distance between the molecule. When we say molecules, any finite volume of a gas contains very large number of molecules. The first thing that come to our mind is the molecule will be very closely packed, but it's not the case. So what we said, molecules are separated by large intermolecular spaces. And when we say large intermolecular spaces, the next part of this statement is in comparison to their own size. Molecules are separated by a distance which is very large in comparison to their own size. So till here we have discussed in previous class. Now we will move forward from there. Now the next postulate. When I say molecules are separated by large intermolecular spaces, what does it mean? If we talk about volume of a gas, remember one thing, when we talk about volume of a gas, in case of a gas, we study two different types of volume. One is known as volume of the gas, which actually means volume of the container in which the gas is kept. And other is molecular volume of the gas. These two volumes are actually different volumes. What I'm saying, if I talk about volume of gas, so volume of gas actually means volume of container in which the gas is kept. Volume of gas means volume of container in which the gas is kept. It is simply like, for example, if I have a container whose volume is 2 cubic meter, if I put 1 mole of a gas in that container, if I put 2 moles of a gas in that container, if I put 4 moles of a gas in that container, volume of the gas will remain 2 cubic meter because the volume of the container was 2 cubic meter. So it doesn't matter how many moles are there. Gas occupy all the space which is available to it. So when I say volume of the gas, it means volume of the container. When I use the term molecular volume of gas, what does molecular volume of the gas means? Molecular volume of the gas means what you will do. Molecules are separated by large intermolecular spaces. What I will do, I will bring the molecules close to each other so that they won't be having any intermolecular spaces. So they will appear like this. And then what I will do, I will measure this volume, the volume which molecules are actually occupying. Obviously, there won't be any comparison. So what we say, molecular volume of a gas is negligible in comparison to volume of the gas, means the volume of the container in which the gas is kept. Now, this statement actually tells you the same fact that molecules are separated by large intermolecular spaces. That's why when they were far apart, they will occupy the whole container. When you bring the molecules together, you remove the intermolecular spaces from among them. What will happen? The volume of the gas, molecular volume of the gas, will be negligible in comparison to volume of the container. Is it clear till here? Okay, Anas is getting it. Summer is getting it. Yes, Hania, Miram. Are you people getting it? Okay. Now, next, what do you think? If I ask, molecules are moving. So remember Brownian motion, molecules always travel in a straight line, but in random direction. Exactly same cases here. If you look at molecular motion, if you look at molecular motion, so what we say, molecules of a gas always travel in a straight line, but in random direction. And this whole statement should remind us of Brownian motion. Molecules of a gas always travel in a straight line, but in random direction. What does it mean? If a molecule is traveling, let's say this is the molecule, this molecule is traveling like this. and other molecule comes in front of it. So this is not possible that this molecule take path like this and then continue to move in a straight line. Molecule cannot do this. Molecule cannot do this. Molecule will keep on moving in a straight line. So obviously it cannot cross that molecule. So what will happen? This molecule will collide with the other molecule and then it will bounce back in some random direction. But one thing is for sure, molecule will keep on traveling in a straight line. Molecules of a gas always travel in a straight line, but in random direction. Why I'm saying random direction? Because you cannot predict after the collision in which direction molecule will be going. But one thing is for sure, no matter what, molecule will be moving in a straight line. So molecules of a gas perform completely random motion. Now, if molecules are performing completely random motion, what do you think? There are two possibilities where molecule will be spending its time. Either it will be performing free motion. Now, when I use the term free motion actually represents this straight line motion. Motion with constant speed. Motion with constant speed, right? In a straight line. So there are two things that can happen. Either molecule will be going in a straight line or it will be colliding. What do you feel? A molecule will spend most of its time in free motion or in collision. So you have to decide this. Yes.
In free motion.
In free motion. Okay, this is Anas. Anyone else?
Free motion, sir.
Free motion. When we talk about molecule spend most of its time in free motion. Why? Remember the previous postulate? Molecules are separated by large intermolecular spaces. So it means that one molecule is here, other is here. Obviously, don't think of this physical distance. It is in comparison to the size of molecule only. So molecule will spend most of its time in free motion in reaching the other molecule. A very small fraction of time is wasted in collision. So the next postulate should be something like this. Collision time. And what it says, most of the time, molecule is performing free motion, number one. Number two, a very small fraction of time is lost in collision. Okay, when I say molecule perform most of the time free motion means motion with constant speed. What does it mean? Is the molecule acted upon by force during that time or there is no force? Yes.
There is no resultant force.
No resultant force. Okay, this is interesting because I gave you just two options. There is a force or there is no force. I mean, if you are using there is no resultant force, it will make a difference here. So I will explain this thing. First discuss what I asked. When a molecule is performing free motion, what do you think? There is a force or there is no force?
No force.
Okay, yes, I guess Miram was trying to say something. Yes, Miram.
Sir, I'm not sure, but I think there's a force.
There's a force. Okay. Yes, Hania, Samar, if you people have any thoughts or any opinion to share.
I don't think so. There is no force.
Okay, see, there is no force is the correct answer. When I say there is no resultant force, now this is tricky. Why? Because we are talking about ideal gases. In ideal gases, we don't have intermolecular forces. When we say there is no resultant force, what I will perceive from this statement, that a molecule is acted upon by number of forces from all other molecules, and they are cancelling the impact of each other. As a result of a resultant force is zero. Anas, were you thinking the same?
Yes, sir.
But remember one thing, we are talking about ideal gases, and ideal gas we say there is no intermolecular force. That's why I say saying no resultant force will make a difference. Instead, you should say there is no force at all. So remember one thing, it is an ideal gas, so molecules are not under the influence of any force. For example, Miram, you said there must be a force. If there is a force, then there must be acceleration. If there is acceleration, then it can't be free motion. Getting it?
Yes, sir.
Okay. So when we say there is no force, why? Because molecule spend most of its time in free motion. So the next postulate should be no force of attraction. By the way, when I use the term no force of attraction, can you tell me which law of physics is being defied by this statement?
Law
No
of
force of
gravity.
attraction. Law of gravitation, if you remember this statement, what did law of universal gravitation says? Every material object in this universe attracts every other material object. There is no exception because statement says every. Statement didn't say most of the material object or almost all material object. Statement says every material object. Every means there is no exception. So this is the exception. So it means that law of universal gravitation is not valid over here. So ideal gases doesn't obey law of universal gravitation. Anyways, no force of attraction, right? In case of ideal gas, force is only where molecules are colliding with each other. Remember one thing, molecules of a gas exert force on each other when they collide. If they are not colliding, they are not exerting any force on each other. Is it clear? Okay, all of you are getting it. Now, when I use the term no force of attraction, and when I said law of gravitation is being disobeyed here, students usually feel all other laws will also be disobeyed. It's not the case. All other laws of kinematics or mechanics or thermodynamics, all are valid on molecules. For example, Newton's law of universal gravitation is not valid on molecular motion in case of an ideal gas, right? But all other laws, Newton's first law of motion, Newton's second law of motion, Newton's third law of motion, law of conservation of energy, law of conservation of momentum, all other laws are applicable on molecular motions. So what is important when we say no attractive forces, it means that molecules of a gas don't obey law of gravitation, don't obey law of universal gravitation. And when we say don't obey, we need to mention all other laws are valid. So all laws of mechanics or thermodynamics are valid on molecular motion. For example, if anyone asks you to find momentum of molecule, you will use the same formula. Momentum is mass into velocity. If anyone asks you to find kinetic energy of molecule, you will use the same formula, half mv squared. If anyone asks you to apply law of conservation of energy, law of conservation of momentum, you can apply. If anyone asks you to find force, so what you can do, force equal rate of change of momentum. These all are directly or indirectly related to laws of motion. I hope you remember that this F equal change in momentum over T is actually Newton's second law of motion, right? So this is a brief overview of kinetic molecular theory. Sometimes in exam, they ask you to write 2 or 3 postulates of kinetic molecular theory. I explain, I guess, 7 to 8 postulates. You can mention any 3 or 4. Now, what we actually need to do, we need to combine postulates of kinetic molecular theory to form an equation which is known as kinetic gas equation. So our topic will be kinetic gas equation. Kinetic gas equation is basically the combined representation of postulates of kinetic molecular theory. In easier words, what you can say, mathematical form of kinetic molecular theory is kinetic gas equation. Kinetic gas equation is mathematical form of kinetic molecular theory. Let's say I have a container. This is a container. I'm just labeling some sides of this container. For example, I'm using A, B, C, and D. What I have done, I just highlight the front face of the container. Why? I will shortly explain. I'm just talking about this, 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 and this. Okay, now it is a container. Let's say length of this container is L. From B to C, this length is L. The cross-sectional area of this container is A. So it will be better if I don't use A, B, C, and D. Because I will represent area by A, you will get confused. So I'm calling it P, Q, R, N, S. And cross-sectional area is A. So when I use the term cross-sectional area, actually I'm talking about this side area. Okay, I'm talking about this whole cross-sectional area. By the way, how to calculate volume? I mean, if you people have taken maths in IGCSE, you can easily answer. Yes. How to calculate volume of a prism? Remember what was prism? Prism is a three-dimensional shape whose cross-sectional area will remain the same. So it's actually a prism because its cross-section will remain same. So how will I calculate its volume?
Cross-sectional area times by length.
Cross-sectional area times length. So if I need volume, what I will say volume of, by the way, okay, I'm calling it volume of container. It should be cross-sectional area times third dimension. So cross-sectional area is A, third dimension is L. So volume will become A times L. Now, if I call it volume of container or if I call it volume of gas, will it make any difference?
No.
Yes. No, because volume of container actually means volume of gas. So volume of gas is A into L. I'm calling it V. Now, if I say I take a sample of a gas which is in this container and we have NT number of molecules. Let's say NT is total number of molecules of the gas, right? And N is number of molecules per unit volume. By the way, I'm using capital NT or N, quite possible. The book you are following, they represent total number of molecules by capital N and number of molecules per unit volume by small n. So symbols are just convention. We can use any notation to represent any quantity till it is well defined. What do we mean by any symbol? Anyways, NT is total number of molecules and N is number of molecules per unit volume. So can you form an equation that can relate NT, N, and V? What should I write? Yes.
N is equal to NT by V.
Okay, N is equal to NTYB. Okay, how many of you actually agree that this equation is correct? Okay, Hania says it's correct. Miran says it's correct. Why it is correct? Just read. N is number of molecule per unit volume. So we have did nothing. We just transformed this statement into symbolic form. N is equal to number of molecule per unit volume. So I said N equal NT over V. So it means that NT is equal to NV. We know that V equal AL. So NT is actually equal to NAL. This is the total number of molecule. Now let's do one thing. If I say behavior of all the molecules of a gas is identical, we just studied kinetic molecular theory. The theory which is valid on one molecule is actually valid on the entire system as well. So what I'm doing, instead of considering the entire system, I'm considering just one molecule of a gas. So let's say we have a molecule of a gas of mass m. We have a molecule of a gas of mass m. So what I'm considering molecular motion of a single molecule. So what I'm saying, let's consider motion of single molecule of mass m. We are considering motion of single molecule of mass m. Now, this molecule must be moving with certain velocity. This molecule must be moving with some velocity. So what I'm doing, I'm considering that velocity as v. And this molecule must be moving in random direction. This molecule must be moving in some random direction like this. Its mass is m. Remember, when we have vector neither on x-axis nor on y-axis, what we usually used to do?
We used to resolve the vector into its components.
X and y component, right? Because there we were dealing with two-dimensional vector. If you look at molecular motion, remember one thing, molecule of a gas moves equally in all directions. Molecule of a gas perform all three types of motion: linear, rotational, and vibrational. A molecule, for example, if you look at a hydrogen molecule, what will be happening? That molecule, let's say this is one atom, this is the other atom. These two atoms forming a molecule, they will be going in a straight line. They will be revolving over each other. At the same time, they will be moving away and coming close to each other like vibratory motion. So molecule of a gas actually perform all three types of motion: translational, rotational, and vibrational. And all three motions are actually identical. The motion of x will be same as motion of y, will be same as motion of z. So this molecule has velocity v. What we did, we resolve this velocity into three components. One is x component like this. I'm calling it Vx. Other is y component like this. I'm calling it Vy. And third one is z component, something like this. Vz. What we have done? Molecule was moving in some random direction, right? So things will be easier for us if we know whether it is going along x or y or z. So what I did, I resolved the velocity into three components: Vx, Vy, and Vz. By the way, do we remember? If we know the x and y component, how to relate it to the magnitude of vector? If any one of you remember that. If you know x component, you know y component, how do you find magnitude of the resultant vector?
Sir, using Pythagorean theorem.
Pythagoras theorem. I hope many of you will be able to recall it. V equal under root Vx square plus Vy square. Because in AS level, we did solve question, for example, in projectile motion, where they used to ask find the final speed or final velocity. We used to use this equation V equal under root Vx square plus Vy square. Since here we are dealing with 3 dimensions, so Vx square plus Vy square, and then we will be having Vz square within a radical sign. Since I mentioned few minutes back, motion of molecule is identical in all the direction. It means that Vy is equal to Vz, and they all are actually equal to Vx. So instead of dealing all 3 dimensions, I can represent this whole thing in sense of only 1 dimension. So it should become something like this. Vx square plus Vx square plus Vx square. It will become under root 3 Vx square equal V. Now, if I want to get rid of this square, I will be squaring on square root. I will be squaring on either side. I will get V square equal 3 Vx square. It means that Vx square is 1/3 of V square. Vx square is actually 1/3 of V square. Because we don't know what is the X component, what is Y, what is Z. So we have formed an equation with the help of which you can easily find with what speed molecule is moving along x-axis. Now, my entire focus will be on this single molecule of mass m, and I'm just considering motion along x-axis. I'm just considering motion along x-axis. So I hope you have all the points of kinetic molecule theory in your mind. Just tell me one thing. Let's say molecule is moving from PQ to RS. It will accelerate, it will decelerate, it will move with constant speed. I will be needing the reason as well. Yes.
It will move with constant speed since there is no force acting on it.
Because there is no for few minutes back we were discussing the same fact that molecule spends most of its time in free motion. There is no force except when molecules collide with each other or with the walls of the container. So when this single molecule is moving, it will keep on moving in a straight line till it collides with the side RS. Okay. If we talk about collision, I guess I forgot to mention this point. When molecules collide with each other and with the walls of the container, the collision is perfectly elastic. I hope you remember from your AS physics what is elastic collision. Yes. Do we remember that what is elastic collision?
It is a collision in which the kinetic energy is conserved.
The collision in which total kinetic energy of the system remain conserved, right? So when molecules collide with each other and with the walls of the container, that collision is perfectly elastic. Now, I will ask a question, then I will give you 2 minutes to think, and then we will resume. Now, listen very carefully. Molecule of mass m moving with velocity Vx towards side Rs. It will collide with Rs. Now, you have to tell me what will happen after that. The molecule will break the wall, come out of the system. The molecule will bounce back in random direction. Molecule will bounce back in the same direction. And what will be the speed of the molecule after collision? I'm giving you 2 minutes. I'm sure you know why I'm giving you 2 minutes. Okay, so take your time, think over it, then we will continue. Okay, so what did we conclude? What will happen after collision?
So the molecule will rebound off the walls.
Okay, direction and speed.
Direction will be reversed and the speed will remain the same.
Okay, and how many of you agree with this? Yes, Hania, Miram, somewhere. Okay, Hania says yes. See why? Because the collision is elastic. Remember that concept of velocity of approach is same as velocity of separation that we used to use in AS physics as well. Now the wall will remain at rest all the time. So if velocity of approach is same as velocity of separation, that was the condition of elastic collision. That is valid only or can be verified only if molecule is moving with the speed Vx towards Rs, collide with it, bounce back with the same speed. I'm using the term with the same speed. Why? Because direction is changing. Previously, the molecule was going towards, now it will be going away. So what we can say before collision. Before collision, molecule is moving from PQ towards RS. I hope I'm using the same notation. Yes, PQ to RS. Quite possible someone of you says that this order is not right. So let me write it SR. PQ to SR, right? With speed Vx. What will happen after collision? Molecule will be moving from SR to PQ. Speed will be the same, but direction is opposite. And I hope you remember in vector quantities, opposite direction is indicated by the negative sign. So when I'm calling it minus Vx, it gives me sense of opposite direction. So if I say calculate momentum of a molecule, because my entire calculation is for one molecule, of a molecule before collision. Remember how to calculate momentum, mass into velocity. So can I say this should be mvx, right? Okay. So what will be momentum of a molecule after collision? Minus mvx. Do you agree? That after collision it should be minus mvx. Now, how will you calculate change in momentum? Change in momentum of molecule. Change is always final minus initial, so you will say minus mvx minus mvx. You will get minus 2mvx. Remember, what does rate mean? If I say calculate rate of change of momentum, what should I do? Yes. How to calculate rate? Yes. How do we calculate rate? In physics, when we use the term rate, what does it mean?
And divide by per unit time.
Time taken.
Per unit time, right? Rate means something divided by time of per unit time. So rate of change of momentum will be minus 2mvx over t. Now, just go back to this diagram and see. Molecule is moving from PQ to RS. So what I'm doing, I'm just considering that rectangle which I highlighted in the very beginning, this one. This is side PQRS. Let's say molecule was moving from this side towards this wall with the speed Vx, then it will collide and then it will bounce back. Speed will be minus Vx. Can you tell me what total distance is traveled by the molecule during this whole time?
2L.
12, because L distance when it was going from PQ to RS, then it will collide with RS, bounce back, it will cover again distance L. So total distance will be 2L. Remember, whenever speed is constant, we can use speed is given by distance over time. Distance will be 12, time is t, and speed is actually Vx. So we can say time is 2L over Vx. What I'm going to do, I will put this value of time in this equation. So if I put this value of time in this equation, what will happen? The equation of rate of change of momentum will become rate of change of momentum is equal to minus 2mvx, remain as it is. And instead of time, what I will be writing, instead of time, I will write 2L over Vx. This 2 and 2 will get cancelled. I hope you remember, denominator of denominator is actually numerator. So it will become L and this will become Vx square. Are you people getting it? Because this is denominator L and this is denominator of that. So actually this Vx will go to numerator. So it will become mvx Vx over L, that will become mvx square over L. How many of you are getting this equation? Okay. So this is rate of change of momentum. By the way, what rate of change of momentum actually represents? Yes.
Impulse.
Impulse. It is close, but it is not correct thing.
It's force.
Yes, Hania. Is it force or impulse?
Force.
Force.
Force. Because impulse was product of force and time. Impulse was product of force and time. Rate of change of momentum is force. Impulse is change of momentum, right? So I can say this rate of change of momentum is actually the force, but which force is it? The force exerted on the molecule or force exerted by the molecule? Now, this is very interesting because we did discuss this point in AS physics as well. When you calculate rate of change of momentum, so which force which we actually get? The force exerted by the body or force exerted on the body? Yes.
The force exerted by the body.
By the body? Okay. Yes. Hania, Miram, Samar, if any one of you wants to share your opinion or thought. Yes, Miram?
Could you repeat your question? Sorry.
Now, my question is, rate of change of momentum is equal to force. This is correct. But which force we are talking about? Force exerted by the body or force exerted on the body? I guess I asked a tough question. By the way, see, when we say rate of change of momentum, remember, I'm just writing here so that you can answer this thing. Change in momentum was mv minus mu over t. Remember, then you used to take m as common, v minus u over t, then it becomes ma, then you say this is F. So which force we actually get from this equation? The force which body is exerting or the force which is exerted on the body? Yes, Anas?
Force exerted by the body.
This F equal ma gives the force exerted by the body.
Yes.
I mean, it's great. No new student in the class today. See, remember the statement of Newton's second law of motion? Anas, because you are answering all the questions, so you answer this thing. Remember the statement of Newton's second law of motion?
Yes, sir.
So, what's that?
Newton's second law.
Yeah, Newton's second law.
The force is directly proportional to the rate of change of an object's momentum.
Okay, there was another statement, and what was that? Whenever an unbalanced force is applied on a body, it produces acceleration in the body in its own direction. Remember this one?
Yes, sir.
So F equal ma is the force which is exerted on the body. F equal ma is not the force which is exerted by the body, because this F is actually the resultant force. Anas, is it making sense?
Yes, sir.
So when we calculate rate of change of momentum, remember one thing: rate of change of momentum is not the force exerted by the body. It is actually the force exerted on the body. So what I can say, the force exerted on a molecule by side RS or SR, whatever you want to call it, doesn't make any difference, will be FA. This A signifies this A, a molecule. We are talking about a single molecule. FA is equal to minus mvx square over L, because force exerted on a molecule is actually equal to rate of change of momentum of the molecule. Now we know that what is the change in momentum of molecule, rate of change in momentum, minus mvx square over L. So this is actually the force which is exerted on the molecule, right? So if this is the force exerted on the molecule, can you tell me what will be the force exerted by the molecule?
Sir, minus of Fa.
Minus of Fa. So can I say, therefore, force exerted on side RS by a molecule will be, and that will be Fa equal mvx square over L. I just omit the negative sign because only difference will be the direction. So this is the force exerted by a single molecule on the side RS, on the wall of the container. Is it making sense? Why did I omit the negative sign? Okay, all of you are getting it. Now, we have number of values that we can put over here, but before that, I would like to perform one more step. How many molecules we had in the sample of gas? One or NT?
NT.
NT. This is the force exerted by one molecule. So how will you calculate the force exerted by two molecules? Yes, if force of a molecule is Fa, so how will you find force exerted by two molecules? Can I say that force should be twice of Fa? How will you calculate the force exerted by three molecules? You can say, sir, that force should be thrice of Fa. So how will you find the force exerted by total number of molecules? You will say, sir, that force is Ft and it is given by Nt times Fa. Is it making sense? Okay, all of you are getting it. Now, what is Nt? Nt is NaL. If I scroll up, you can see Nt is NaL. I just highlighted in yellow color, right? So Nt is NaL, and the value of Fa is mvx square over L. L and L will get cancelled. So we will end up with NaMVx square. By the way, this Vx square is, we have calculated somewhere here. Vx square is 1 over 3 V square. So put it over here. So what will it become? It will become NaM 1 over 3 V square. This is the value of Ft. Actually, what I was trying to do, I was trying to drive a relation which is known as kinetic gas equation. And kinetic gas equation is actually equation of pressure of the gas. So I need actually the pressure. So any idea how to obtain pressure from this equation?
Pressure is force per unit area.
Force per unit area. Luckily, we have area on the right hand side as well. So what I can do, Ft over A is equal to 1 over 3 mn v square. I simply arranged it. This Ft over A is pressure. So P equal 1 over n v square. This is kinetic gas equation, but there are a few flaws or error in this equation that we will be rectifying. But now, what point I need to make? During the course of this derivation, we did use Newton's second law of motion. We did use Newton's third law of motion. So can you relate? All laws of mechanics are valid on molecular motion, despite of the fact law of gravitation is not valid, but all other laws are valid. We use the concept of free motion. We use the concept of elastic collision. So whatever we have discussed in kinetic molecular theory, actually we transform all that theory into mathematical representation in the form of 1 over 3 mn v squared. Is it clear till here? If it is clear, so that I can discuss the flaws or error in this working. Now see, we wrote one step. I'm highlighting that step in orange color. This one. When I wrote this equation, what I actually assumed, I assume that all molecules are exerting same amount of force. It is just like, including me, we have 5 people in this class, right? Let's say each of us got 10 dirhams. If anyone asks what is the total work, what you will do? You won't be doing 10 plus 10 plus 10 plus 10 plus 10. What you will do? 5 into 10. Because all got the same amount of money. All you need to do is just multiply value of 1, multiply by the number of students. Is it making sense? What if all of us got different amount? Let's say I got 5 dirhams with me, Anas got 50 dirham with him, Hania got 30 dirham, Miran got 20 dirham, Samar got 50 dirham. We all got different amount. Can we do this thing 5 into certain number, or we need to calculate separately and then add them together? Yes.
Calculate them separately and then add them together.
Add them. When I wrote Ft equal NTFA, I actually assumed that all molecules are exerting same amount of force. That's why I said to find the total, just multiply force of 1 by the number of molecules. And when I say all molecules are exerting same amount of force, just look at this. M is molecular mass. So I hope you will agree. In a sample of a gas, is it possible that value of M gets changed? Yes. In a sample of a gas, is it possible the value of small m gets changed?
No, sir.
No, sir.
No. Why? What was this m? This m wasn't the mass of the gas. This m was molecular mass of the gas. I guess I did mention somewhere C. Let consider motion of a single molecular mass m. So m is molecular mass. If it is hydrogen, it will always remain 2. If it is nitrogen, it will always remain 28. If it is oxygen, it will always remain 32. If it is carbon dioxide, it will always remain 44. So the thing is, this m is always constant. What about this L? L is the distance between the two sides. It will always remain constant. So when I said all molecules are exerting same force, I actually assume that all molecules are moving with same speed. Do you agree? When I said all molecules are exerting same force, I actually said that all molecules are moving with same speed. Why? Because force is mvx square over L. M is already constant, L is already constant. If Fa will remain the same, it means that Vx is the same for all the molecules. So this equation is actually driven on the assumption that all molecules are moving with same speed. This equation is actually driven on the assumption that all molecules are moving with the same speed, which is not the case, which is actually incorrect. All molecules of a gas are not moving at the same speed. So when all molecules are not moving with the same speed, it means that all molecules wouldn't be exerting the same amount of force. If all molecules are not exerting the same amount of force, then this orange working is actually incorrect, right? Now just keep on looking at the screen so that you get the idea. Let's say on x-axis we have speed. On y-axis we have number of molecules. Right? We plotted a graph between speed and number of molecules of a gaseous system. What we observed? We observed some graph like this. Now, those who have taken stats and AS level, they must remember this graph. This is normal distribution actually. And those who never studied mathematics, this is the first and the last time we are discussing this thing. So you don't need to worry about it actually. But what matters, you are in position to interpret this graph. What this graph is actually representing. Look at this point. Can I say this is the point where speed is lowest or minimum? Yes or no?
Yes.
Yes. This is the point where speed is maximum. Yes or no?
Yes.
Yes.
Yes. But look at the number of molecules which are moving with lowest or maximum speed. They are minimum. They are minimum. This graph actually shows that a very small number of molecules are moving with very low speed or with very high speed. Can you tell me at what point molecules are moving, or at what point largest molecules are present? This one? This one, at this point, number of molecule is maximum for this graph. Right? And if I say calculate the velocity or speed at this point, you will draw perpendicular. You will get a point like this. This one. Can I say this velocity is actually average of minimum and maximum? It is exactly or almost in between the minimum and the maximum. So what I can say, very small number of molecules are moving with very low or very high speed. Majority of the molecules are actually moving with average speed. So what we actually did in this equation, this V squared is actually replaced by this thing, or you can call it V squared bar, which actually means average speed, which is known as average speed. So equation will become 1/3 m n V squared, right? So in the equation of pressure, we don't have a square of speed. We have average of square of speed. Now, this is actually very interesting. Let's say in a molecule we had, and in a sample we had anti-molecule. So how will you calculate this V square and then average? You will be doing this one. V1 square, V2 square, V3 square, and so on till VNT square. All the molecules, you take their speed, you score them, you add them. How to find average? You need to divide it by NT, right? You need to divide it by NT. So the equation now which we will be having is known as kinetic gas equation. in exam, they do ask to drive this equation as well, right? While driving, I explain everything. So I hope majority of you are getting it. Let me explain 2 or 3 more things related to this one. Then I will take any question if you will be having any doubt or any confusion. Just tell me one thing. What should be the unit of average of square of velocity? I mean this quantity. You have studied physics in IGCSE level, in AS level. Now you are in A2 level. So I believe you should be knowing what should be the unit of this V square. Yes.
Meters per second.
Meter
Per second.
This is V square actually. If it is
So
V square,
meters,
so
yeah,
it's
m square s minus 2.
over second square. Meter square over second square, or which you can say meter square second square inverse. I guess Mira, you were trying to say this last one, right?
Yes, sir.
Okay. So if you need the value of speed, what you need to do, you need to take square root of it. So this is actually very interesting. V square, you will take square root. This is known as VRMS. Actually, in this name, the entire derivation or concept is there. What is this? It is root mean square speed. See, this is root, this is mean, this is square, and this one is speed. So what is VRMS? VRMS means square root of average of square of speed of molecules of a gas. Sometimes in exam they ask you to define VRMS. What is VRMS? VRMS means root mean square speed, and how will you define it? VRMS means square root of average of squares of speeds of molecules of a gas. How many of you are actually getting it? What is VRMS? Okay, so this was the one thing that I wanted to explain. One last thing. Do we remember how to calculate density?
Mass per unit volume.
Yes. Mass per unit volume. So density is given by mass over volume. Now, there's a serious problem with this formula. V is volume of the gas, and this M is mass of one molecule. So you have two possibilities: either calculate volume of one molecule, that will be little difficult for us, or calculate mass of the whole gas. Any idea? If mass of one molecule is M, how will you find mass of entire gaseous system or gas? Yes.
NTM.
Yeah, and
Okay. I hope all of you getting it. The density is mass over volume, but M is unfortunately mass of one molecule. We need mass of total gaseous sample. So it should be MNT over V. By the way, what is this? NT over V.
N.
N. So it will become Mn. It means that density is M into N. So density is M into N. This is M into N. So can I say the pressure equation is actually 1/3 rho V square average. This is another form of kinetic gas equation. P equal 1/3 rho and average of V square. One last thing. I use this symbol with which we are actually very familiar, that speed is denoted by V. But in many books of Cambridge, this speed is actually denoted by C. For example, the most common book that majority of you might be using for your AS level physics, you use for your AS level, and you will be using the same in your A2 level, that is that St. John's book. In that book, speed is denoted by C. So if I call this equation like this, P equal 1/3 rho C square. So it is actually one and the same thing. So don't get confused by these symbols. Don't get confused by the symbols. So this equation is actually known as kinetic gas equation. So if any one of you have any confusion related to it, feel free to ask. I did mention in previous class that this is the longest derivation of your, you can say, A2 level. We won't be having any lengthy derivation like this. We will surely be having derivations, but none of them will be as lengthy as this one. So I'm giving you 3-4 minutes. Just think. If you have any confusion, you may ask. Otherwise, we will see what we should do next.
Sir, could you please scroll up a little? Sir, for the mvx squared divided by L, you said that you removed the negative sign, yeah?
Yes, because minus mvx square over L was the force exerted by a molecule. In fact, on the molecule. If you need the force exerted by a molecule, so Newton's third law of motion, action and reaction thing. So I just removed the negative sign. Getting it?
No, sir. Could you please explain it again?
Okay, see. Remember, we used to say action and reaction are always equal in magnitude but opposite in direction. Remember?
Yes, that's the third Newton's law. Yes.
Right. So when molecule collide with the wall, with this wall RS, what force is exerted on the molecule? This one, which I'm highlighting in yellow color. This is the force exerted on a molecule.
Yeah.
Right? No.
So it doesn't
The
matter.
force. This is the force which is exerted by the wall on the molecule. So
Yeah.
what force molecule will be exerting on the wall? This is action reaction. So if action is minus mvx square over L, then reaction should be mvx square over L. Getting it?
Yes, sir. Yeah, I got it. Thank you.
Okay, so any one of you having confusion or doubt, feel free to ask. Well, what I'm doing, I'm just sharing these notes with you on WhatsApp so that you can go through the topic. I guess I didn't share the last class notes, right?
Yes, sir.
Well, sir,
So I'm sharing both. I'm sharing both. By the way, did I share this one?
Yes, sir.
yes,
Okay.
sir.
So it means that last two notes are due to share. Okay, just share both the notes. Okay, just go through it. Uh, if you will be having any confusion, I will clear. Otherwise, we will proceed from here. So just go through it first. After 5 minutes, I will take your
Sir?
Yes, ma'am.
Sir, could you please explain the kinetic molecular theory of the second and third point you gave?
In the previous class?
Yes. Yeah, the second.
Okay, it was actually, yeah, large number of molecule. If you take any finite volume of a gas, let's say 1 cubic meter, at STP, standard temperature and pressure, we will be having 3 to 10 to the power 25 molecule, which is a very large number actually. So what we say, any finite volume of a gas contains very large number of molecules, right? And when I say very large number of molecules, it gives me impression that molecules are closely packed. So it's not the case. Molecules are separated by large intermolecular spaces in comparison to their own size. Getting it?
Sir, could you repeat the last point? About the
When we say any finite volume of a gas contain very large number of molecules,
Yeah.
right? It gives me the impression that molecules are closely packed because they are very large in number, but it's not the case. I gave the example. If you take just 1 centimeter between two molecules, that distance is 1 into 10 to the power 8 times of the molecular size. So that 1 centimeter distance is actually very large in comparison to the size of molecule. Getting it?
Yes, sir, I did get it. Yes, thank you.
Okay,
And
so
sir-
if any one of you have, yes, Meena.
And sir, may I know what's the theory for the first point?
Definition of molecule.
That's it?
The theory of first point was actually the definition of molecule. That what is molecule? Molecule is the smallest particle of substance which can exist freely in nature. That actually came from kinetic molecular theory.
Yeah. Thank you, sir.
Okay, so we will resume from here in next class now. If any one of you have any doubt or any confusion or question, you may ask. Otherwise, we will resume from here in next class.